this will give you what sigma 1 minus sigma 2 sine 2 theta equal to minus 2 tau cos 2 theta. Or theta equal to 1 by 2 tan inverse minus 2 tau by sigma 1 minus sigma 2. So this theta corresponds to the inclined plane with maximum normal stress. Another thing which you may have to note is principal stress. Actually, it is principal stress is that stress in a plane where the shear stress is 0. When shear stress is 0, that plane is called a principal plane, and normal stress on that plane is then principal stress. So for this, what we have to do for finding that inclined plane where shear stress is 0, that corresponding theta can be found out from the equation. That is, we know sigma t is given by sigma 1 minus sigma 2 by 2 sine 2 theta plus tau cos 2 theta. So this is equal to 0 implies that theta is nothing but 1 by 2 tan inverse 2 tau by sigma 1 minus sigma 2. So we have already seen normal stress on an inclined plane of inclination theta with vertical is given by sigma 1 sin square theta plus sigma 2 cos square theta plus 2 sin 2 theta, and along that inclined plane or sigma t is given by sigma 1 minus sigma 2 by 2 sin 2 theta plus tau cos 2 theta. Now this can also be written as, if sin square theta is given as 1 minus cos 2 theta by 2 and cos square theta as 1 plus cos 2 theta by 2, then this can also be written as sigma 1 minus sigma 2 by 2 plus sigma 1 minus sigma 1 minus sigma 2 by 2 cos 2 theta plus tau sin 2 theta. And if I am getting this sigma 1 minus sigma 2 to this left hand side, then it becomes sigma n minus this term is equal to so and so, but with a negative sign. So equation 1 and equation 2, from this equation 1 plus 2, you will be getting sigma n plus sigma t as sigma 1 minus sigma 2 by 2 plus tau times sine 2 theta plus cos 2 theta. In the first case sigma n, we have a negative sign there. So if I am taking sigma n minus sigma 2 by 2, cos 2 theta is becoming negative. And here it becomes negative. So if we are cross multiplying and seeing, we will be getting so and so sigma 1 minus sigma 2 by 2 sine 2 theta plus minus tau sine 2 theta and minus sigma 1 minus sigma 2 by 2 cos 2 theta plus tau cos theta. And if I am sigma n minus sigma t, and sigma n minus sigma t can be similarly given as sigma 1 minus sigma 2 by 2 minus tau times sine 2 theta plus cos 2 theta. Next, on solving, we will be getting sigma n dash minus sigma t and sigma n dash plus sigma t, so and so. And again, sigma n dash square plus sigma t square, you will be getting a constant which shows this can be represented as a circle, and that is nothing but Mohrs circle, which gives the whose coordinates are sigma n and sigma n dash and sigma t. That is, I will show you. If we have a circle like this, at any point the coordinates will be giving you sigma n dash and sigma t, where sigma n dash is nothing but sigma n minus sigma 1 minus sigma 2 by 2. So this we have taken before so as to obtain that equation. So that is how we get Mohrs circle. And for any inclined plane, inclined at theta angle, what we have to do is so at theta equal to 0, you know, the only stress is sigma 1. There sigma n dash is what? Sigma 1. Sigma n dash is what? This much only. That is sigma 1 minus, and this thing you will be getting sigma 2. That is at theta is equal to -90 degree, which shows you that any angle of inclination in real, if any angle of inclination in real, that is, when we had a 90-degree inclination, what is the stress? When we needed to find what is the stress at an inclination of 90 degree, what we have to look? We had to look for, in the Mohr circle, we went by 180 degree. So for obtaining stresses on an inclined plane with an inclination theta, you have to look for the coordinates of the circle at an inclination to theta. So I think you are getting my point. So also see here we went anti-clockwise 90 degree. Suppose from origin of circle we are considering, from left side, that is what we write. We have to look for an so this is the direction of sigma 1. From that have to go anti-clockwise by 2 theta. I will show here again. It is you have to go clockwise. Here if theta we are considering, we have to go clockwise. Then here we have to go anti-clockwise for 2 theta. That is with what? From vertical only. So from sigma 2. From sigma 2 you have to go by 2 theta. And there again you have to find the coordinates. Sigma n and sigma t. Either you can do that way, or this is sigma t and this is sigma n dash. Sigma n is what? Sigma n dash minus sigma n dash plus sigma 1 minus sigma 2 by 2. That is this much thing. Have to add that for getting the real sigma n. So that's how we analyze inclined planes using Mohr circle. Again this is again to find maximum stresses and all, maximum principal stresses. So you know how to find that theta. That is tan inverse minus 2 tau by that theta. So 2 theta is what? Tan inverse minus 2 tau by sigma 1 minus sigma 2. So that theta you have to take in Morse circle. To theta. So with the vertical, so from here you have to go by 2 theta and find corresponding principal stress. And maximum stress is this one, shear stress is this one, maximum shear, if that is the maximum shear stress, what is it equal to? Radius of the circle. That is, I will show you.